Hello friends, welcome to Databricks video tutorials. In this ongoing Pyspark real-time scenarios, today video I'm going to give you one of the real-time scenarios, difference between Coalesce and repartition, and when we will use Coalesce, when we will use repartition, and we'll understand practical session the major difference between these two transformations. Okay, let's create one notebook. Let's create one notebook. Coalesce and repartition. Coalesce and repartition. So today primary focus is understanding major difference between Coalesce and repartition. Difference between Coalesce and repartition. So this is one of the common scenario, and even interview point of view also this is very important. Let's understand RDD level, data frame level. RDD level, data frame level, there is a difference. And if you are using at RDD, what is the difference? If you are using a data frame level, what is the difference? That we will see now. I'm going to create one RDD using Spark context parallelize method, and I'm going to give input as array 0 to 9 numbers, and default I'll go with 4 partitions. Okay, I'm going with the 4 partitions. Let's verify the data partition wise using a glow function and display the data using collect. So 4 partitions are created: partition 1, 2, 3, 4. My requirement is decreasing number of partitions to 2. 4 is available, just decrease to 2. So if you want to decrease the number of partitions, you can use a Coalesce or you can use a repartition. Both works for that. Let's create RDD1, existing RDD. I'm going to apply Coalesce and decreasing to 2. Again, I'm going to create RDD2 and existing RDD, apply repartition, then 2. So 2 RDDs are created. Let's print the data on all 3 RDDs. This is the original RDD. Gloom collect. If you want to display multiple output, use a print function. Okay. If you're not using a print function in notebook, it will display only one output. Like multiple collects we are using, right? RDD1, RDD2. This is for Coalesce. This is for repartition. Repartition we decrease to 2. Even Coalesce also we used, we decrease to 2. Let's verify the output. Let's verify the output. We'll understand the difference. So let's look at the example. This is the input RDD, partition 1, 2, 3, 4. And we used the Coalesce and we created a new RDD to reduce to 2 partitions. Now you see this partition 1, partition 2, it is created. Then we used repartition as well. Then created a new RDD. Then this is the new RDD data output. You see this. We used a glow function to display data at partition wise. And this is 1 partition and 2 partition. Then what's the difference between Coalesce and repartition? If you observe carefully, and even if you look at the job details as well, go to the 3 jobs. The first job is this one, input RDD, 4 partitions, so 4 tasks it is submitted, and a single stage. The second job, which is a Coalesce, RDD1, that is 2 tasks it is executed, and the output RDD is 2 partitions. The third one here is, you see this, it is executed 2 stages. And the difference here it is, if you go and view Coalesce job, it is applied a Coalesce. You don't see shuffle write, shuffle read operations. 2 partitions it is processed as a 2 task. But if you look at this job, which is a repartition job, and you see this shuffle write, shuffle read, this step is very important. Shuffle write, input 4 partitions written in memory, then while reading as a 2 partitions, that is a shuffle read. shuffle right, shuffle read step is there. So repartition is recreated new partitions. Let's understand the difference again. Coalesce will adjust data in existing partition. Coalesce won't shuffle any data. There is no shuffle right, shuffle read. You see this narrow transformation, narrow transformation. Repartition is newly created two new partitions, and it is shuffled. Shuffled is nothing but there is a two steps. Shuffle right, shuffle read step was there. So this is wide transformation, and if you look at this, these two partitions are newly created partitions. This is newly created partitions. But when it comes to Coalesce, the same partition, it is adjusted data, existing partitions only it's used. It is adjusted data in nearby partitions. Coalesce uses only adjust data in nearby partitions. Nearby partitions. Now, when to use Coalesce, when to use repartition. If you have a requirement to decrease, to avoid shuffling, to get a better performance, use Coalesce. Because when it comes to decreasing, Coalesce won't do shuffling. Repartition will do the shuffling, because in this scenario, Coalesce is narrow transformation, repartition is wide transformation. Look at another example. For decreasing, I want to decrease to 4. Okay, let's recreate this. Existing input is 4. I want to decrease to 6 partitions. Okay, now let's look at the output again. So 4 partitions, which is input RDD, and Coalesce, again you see 4 partitions. It is not increased. Coalesce by default, it works for only for default. It works for only decreasing number of partitions. But when it comes to repartition, it works for increasing or decreasing number of partitions. Now you see this is created 6 partitions, partition 1, 2, 3, 4, 5, 6, and even job also you see shuffle right, shuffle read will be there. Input is 4, output is 6. Input is 4, shuffle right, output is 6, shuffle read. So by transformation, shuffle right, shuffle read will be there. Coalesce, input is 4, output also 4. It is not increased. It is not increased. Coalesce by default, it won't increase. But still, if you want to use Coalesce for increasing, RDD level, there is a Coalesce function. There is an option called the second argument. By default, it is optional, which you can specify a true. That is called shuffling. If you specify the second argument true, then Coalesce will become same as like repartition. Now you see this. 6 partitions it is created. You see this partition 1, 2, 3, 4, 5, 6 partitions. Even job also you see this. This is shuffle right, shuffle read. Even Coalesce also is doing shuffling. 4 partitions written, shuffle right, 6 partitions read, shuffle read. So RDD level API, Coalesce is having a second argument. By default, it is optional. You can specify. Go to the documentation. Spark RDD Coalesce documentation. You can go to that documentation and verify the source code. Here is the source code. This is the standard documentation from Spark website. And verify the Coalesce. Default, we will go with a minimum number of partitions which you want to decrease. But there is another argument called shuffle. The default is false, which you can specify this. Which you can specify, then it can shuffle the data. This is. So by decreasing, if you want to decrease, it won't do any shuffling. Only for increasing, it will do the shuffle. Even when it comes to decreasing, if you want to do the shuffling, that argument by default is false. By default is false. Then look at another example with data frame level. Because nowadays we are not using RDD, we are going to use a data frame. Let's create a data frame using a Spark Read API. I have some CSV file. I'll show you that CSV file it is available in my mission. It's employee table data. It is having some departments. What is employee data? Let's take this example and create one data frame and understand here. Go to file, upload this data file. I'm going to upload into under file store, tables location. It is available in my local machine. File is uploaded. File already available. It's a default. It's renamed as F4. Copy this file name and provide this. And provide a header because it's a CSV file header is available and create the data frame. This is the data frame. The data frame, and even you can verify how many partitions are available. Okay. So by default, if you want to use get num partitions, so this function is not available at data frame level. So which you need to convert into RDD, then you can use this. Only one partition because it's a small file. Data frame default, if you don't have a more than 128 MB data, it will create a single partition. Okay, single partition. So this data frame is having only single partition. Now let's show you the data first. Display df. This is the data. So employee data and department wise data also is available. So one partition. Now what I'll do, I'll create a new data frame, applying a transformation, a repartition. So repartition, then I will create 4 new partitions. Then I'll add another column using a with column, partition ID. So there is a function called spark underscore partition underscore ID. So using this function, which you can create a partition column and import this function from pyspark.sql.functions. So Pyspark is a library, SQL is a module, functions is the class. Import that function from that class. This one. Now create, and I'm doing repartitioning 4, and I created a column partition column. Let's verify the data in new data frame. I created a new data frame. Now you see this. I will go with show option, which text to table format it will display. You'll get more clarity. Yeah. Let's observe the data here. Partitions it is created. Partition 0 and the department's data. You see this. Partition 1, partition 2, partition 3. Total 4 partitions. Total 4 partitions. Okay. Now, and whenever you go with a default, like increasing partitions, you can use a repartition. But when it comes to data frame level, Coalesce is available. That also I will show you. Now, same thing. If you go with the Coalesce, if I give a 4, by default, Coalesce cannot increase number of partitions. So only one partition it is available now. The second argument, earlier we specified a true, right? But that is applicable only for RDD level. This is data frame. Data frame API is different. I'll show you the documentation. So Pyspark data frame Coalesce. Just I'll show you the documentation. Okay, this is the documentation, and this is data frame level. Go to this. You see this. RDD level, we saw there is an argument called shuffle. Default is false, which you can specify the second argument. But data frame level, you don't see that. Data frame level, you don't see that option. Because data frame level Coalesce is available, but the second argument is not available. So it will work only for decreasing, not for increasing. And if you observe repartition will have an additional argument called columns. That also I will explain that. Data frame level. Still, if you want to increase, then convert into RDD first. Then use this Coalesce 4. Then convert into data frame again using a 2DF. Because data frame level, this you cannot use true, because that function transformation, the nature is without shuffle. But RDD level is with shuffle is available. Now I converted into RDD, then I applied that, then I created. Now you see, the problem is because column specific we are not done, default it's created 4, but you see only 2 partitions. You see only 2 partitions. Then what about another 2 partitions? We increased to 4, right? We increased to 4. Let's verify here. Get number of partitions function, convert into RDD. Then you see this, 4 are there, but only we see 2 partitions. 2 are empty partitions. Let's go and collect the data, and we can see now. Partition 1, partition 2, partition 3, partition 4. So there are 2 empty partitions it is created. Then partition ID also you see 0. This is partition ID 0 and partition ID 3, the 4th partition. So 1 and 2 partitions is created as empty partitions. There are some chances it can create empty partitions. Now, and Coalesce data frame level default, you won't shuffle. Default is narrow transformation. You cannot make Y transformation. If you want to make a Y transformation, first convert into RDD, then use that. If you're not converting into RDD, then it will raise exception saying that 2 arguments. So syntax issue. Okay, next go with repartition again. So repartition, what I will do, I'll go with a column specific. I'll go with a column specific. If you observe carefully, partition 1, nothing but partition 0, index 0, and this column data, because we specified this column as a partitioning column. Now this column data is created separate partition, and this data created separate partition. So partition 1, 2, 3, in between there is one partition that is created as empty partition. There are some chances it can create empty partitions. Okay, a total 4 partitions are available, but the data is splitted accordingly. Data is splitted, column specific data. Now, this will help you when we will go with the repartition, right? So when you go with the repartition you can blindly split into 4 partitions, or column specific data also you can split. This is the second argument which is available here. In repartition, the second argument which you can go with the columns specific, which you can split your data. This will help you mainly when you are joining a tables. This will help you, because if partitions, same partition is having a different values, when you're joining with another table or another data frame, and if you have multiple partitions, and if let's consider if you don't have a proper data in a partition wise, the data, if you look at this partition is having a 10, 20, 30, you see this. But another partition, when you're joining with this, if that partition is having only one value, then you won't, it is shuffling the data. Okay, so to avoid that, even you can create partitions based on column specific. That's the difference here. RDD level difference between Coalesce and repartition is, by default Coalesce is narrow, it won't do the shuffle, and repartition is wide, and Coalesce you can use for only decreasing, repartition you can use for increasing, decreasing. And RDD level, Coalesce which you can use a second argument, which is a true, shuffling is true, which it will work for increasing as well. RDD level, it will work for increasing as well. When it comes to data frame level, Coalesce works only for decreasing, it won't work for increasing. But repartition works for increasing and decreasing. It's a Y transformation. It's a Y transformation. Even you can use additional option is a column, which you can split number of partitions based on particular column data. Based on particular column data. So it will be available, it will be slitted and stored. When you are storing this data into file, then it will, one file it will store this data, one file it will store this data, one file it will store this data. Okay, so this way which we can go with the Coalesce and repartition. Always remember, Coalesce data frame level nature is different, RDD level nature is different. RDD by default is only for decreasing, but you can use for increasing using this option. And repartition you can use for increasing and decreasing. So if your requirement for decrease, use only Coalesce. Then when it comes to data frame level, Coalesce works only for decreasing, it won't work for increasing. Data frame level. Even I have shown the documentation as well. This is a standard documentation. And data frame level repartition will have another argument. This is columns. Columns wise, you can split the data. So column specific data wise, you can create a partitions. This is called hash partitioning. Hash key basis. We are giving a department number. The department number hash key basis, it is doing a partitioning. This is one of the best partitioning. Will help you to improve the performance when you are joining a tables. That's a repartitioning. The repartitioning you can use for increasing. Most probably will be using a data frame. Data frame, when you are using a repartitioning, choose a column, frequently joined column or frequently filtered column. Then it will do the repartitioning of that column specific. It will give you better performance. Then when you go with the Coalesce, you can go with the decreasing number of partitions. That's all. That's the major difference between Coalesce and repartition. If you like this video, please subscribe my channel. See you in another video. Thank you. Have a good day.